find the curvature of the curve, and the point is not specified, so at any point t. Here is the curve, and we know the formula to find the curvature. Here is the case. Just find the first derivative, and again second derivative, find the cross product, and take the magnitude that goes on the top. On the bottom, magnitude of r prime cubed. Okay, so let's find the derivative of this curve, vector valued function. So we need to find the derivative of each component. So this is root 60 squared, so 2 times root 60, just 2, 60 squared. Let's find derivative one more time. That's the second derivative. So just 2 root 6, derivative 2 is 0, 12t. And let's find the ingredients needed for curvature. So let's find the magnitude of r prime. So magnitude of this, which is first component is squared plus 2 squared 4 plus 6t squared is squared, 36t to the fourth. And this square means 2 squared 4 times root 6 squared 6. 4 times 6, 24 t squared. And now we got 3 terms, and we can factor 4 out. This is inside radical sign, and that leaves 9t fourth plus 6t squared plus 1. That's on the top. We can factor this. In fact, square root of 4 is 2. And this, if you factor, this is 3t squared plus 1 times itself. So 3t squared plus 1 quantity squared. And when we take a square root, we write this. But I'll wait. I don't want to spend time just to factor this. Okay. And next we need for top, so let's find the cross product of r prime and r double prime, ijk. So this is r prime, r double prime, and using for I we just remove row and column. 2 times 12t, that's 24t, minus this side 0, just 24t. For j we put negative in the front, and we multiply this way. 2 times 12, 24 root 6 t squared, 24 root 6 negative 24 root 6 t squared, minus this is 6 times 2, 12 root 6 t squared. Okay, 24 root 6 minus 12 root 6 is 12 root 6 t squared, and negative. That goes on the middle. For k, okay, this is this vector. We don't write anymore since we are using component form. For k, this is 0, so minus 2 times 2, 4 root 6. So this is the vector r prime cross r double prime. Now we find the magnitude of this. That is needed on the top. So the magnitude is 24t squared. I am just writing 24 squared t squared plus negative square will be positive. So 12 squared root 6 squared is 6 t fourth plus, because negative square will be positive, 4 squared 16 times 6. Okay, now 16 times 6 is 96, and we have a number, and 24 squared. 96 divides these two numbers, so we can factor 96 out inside radical sign, and I'm writing the highest exponent first. Divide 12 squared times 6 by 96, that gives 94, and here plus 60 squared, this is our plus 1. Look at the top here, we have same thing on the top end. This goes on the top, this goes on the bottom, so we can factor, but we don't have to. Okay, now this goes on the top, and this cube goes on the bottom. Okay, thus the curvature kappa is, by formula, this goes on the top, so let me write in this way. This is root 96 times root 94th plus 60 squared plus 1, all over. If we go up, this r prime, this cubed, okay, so root 4 outside cubed, and 94th plus 60 squared plus 1, 3 copies, okay. 1 copy, cube means 3 copies, so this 1 copy, and let me write 2 copies here, that means e squared, and e squared and e squared would cancel, so we have 94th plus 60 squared plus 1, okay. Root this 3 copies, 1 copy here, 2 copies here, so root this square means cancel. Now these two things are same, so we can cancel from top and bottom, and whatever is left over is the answer, okay. So root 96, this is 16 times 6, so root 16 is 4 root 6 over this is 4 root 4, so 4 cube means 1 copy, from 2 copies of root 4 we get 4 root 4, and this you can factor if you like, which is not needed. If you factor, this becomes 3t squared plus 1 quantity squared, 4 cancel, and this is in fact root 3 halves, so you can write in this way, root 3 halves times 1 over, you have 3t squared plus 1 quantity squared, final.